Okay, thank you, Dan and Nico. We are really happy to be here. We were here last time just, to drink beer and then realized this is such a fun group, we should do something. And so Nico had to do some arm twisting, and then, we agreed that we'll do some talk. But talking about standards that's going through standard bodies is very dry. I'll try to make it a bit more interesting, but we realized that it's more fun to do some demos of what we've been doing with it. So I'll do the very dry part, and then my colleagues here will do more funny stuff with it and do some demos. Start out with introducing ourselves. I'm Gaurab Upadhaya. That is the presenting team. I'm an architect in the streaming media at Oracle Cloud.
I'm Matthew Young. I'm a consulting member of technical staff, also on Oracle Cloud and Oracle Media Services.
First name's AI. I go and principal member of the Oracle for the media.
Thanks, you guys. Want to stand here or sit there? Up to you guys. So, so today I'll talk about. I think my first slide I missed that out. Mock. And there is some joke going on around whether we should call it mock or mock, whichever is stickier. But there is a trend to, instead of calling it media over QUIC, to just refer to it as mock. Just like quick become quick. So I use that there. That is what you'll probably keep hearing going into future rather than people calling it MOQ. We're just going to start hearing mock. And yes, so that is there. We'll go straight into it. I went through this. So why mock? And a lot of us here probably already are very familiar with where this came from, why it started. But why mock appeared? And anyone, mainly, I think there are two interest groups that have pushed for mock in the IETF. Folks who do video conferencing, and folks who do live streaming of sports, concerts, or whatever. Mainly sports live streaming. Those are the two groups of set of people who wanted a low latency solution for video streaming. And that is where what we have today with HTTP. HTTP was really good. It solved a big problem with scale, video delivery, VOD, but it left out the low latency bit, right? I mean, those of us who've been around long enough probably wanted to go back to RTMP because it did it live really well, or Adobe Flash, but those are things of the past. So HTTP worked really well, and HLS and DAS made it very friendly, cache friendly, and we could use CDNs. It's scaled with Google bringing out QUIC and adopting that for YouTube, and it brought in UDP transport and faster setup, so it became the substrate for most of the video streamed. Not quite so everything, but quite a lot from YouTube. But at the same time, as more and more video went on over the internet, people wanted lower and lower latency. And I think with the pandemic and the rise of video conferencing, delays and, oh, it is working, it is not working, spending half the time trying to figure out if the tech is working or not become unacceptable. And, I don't know how many of you remember, but in the early days of the pandemic, Zoom had a lot of trouble. And I used to work at Amazon back then, and I kind of saw it, the difficulties in scaling them up, not just video part of it and so on. So that probably gave it a bit more push. And so the IETF, the Internet Engineering Task Force, the standards body, already was standardizing HTTP3, so the mock working group, media over QUIC, set up. The charter basically at IETF always starts out with a simple thing. And you need to get me really drunk to start talking about it for long, but it starts with a very simple charter, and it keeps on getting complicated and complicated and complicated before it becomes a standard. But that is the standard making process. you see. But it started out with a very simple charter for low latency ingest and distribution. And one of the early things was like, hey, multicast worked really well for video, and we should take all the things at multicast that worked well for video and try to replicate that, because multicast never worked in the internet across network boundaries, right? And so I think that kind of copied into. So some of those concepts of multicast, some of the requirements of low latency, like with the WebRTC, and a bunch of things got jumbled together, as it happens in standard bodies, and we got the working group. So this is the protocol in one slide. MOQ is mainly a transport specification. It can carry any kind of video. It does not care about the format of the video, but it cares about the transport. So this is very media agnostic. It's a pop sub, protocol. You can run it over QUIC or web transport. Web transport for browsers, QUIC for almost everything else. I have a more detailed slide next, in a few more slides down there, but your publisher receives the video, that is the ingester. It publishes, and some relays in the middle that basically subscribe to the publisher video. And then the subscriber is the client that basically, the publisher publishes, the relay relays, the subscriber gets the video. So very simple, and then you can run applications on top of it. Very simple. The objects are divided into subgroups, groups, and tracks. I have a slide that comes into the next one where we talk about the data model. By the way, everything I talk about protocol here is what we call draft 18 that came out about in May. We went from draft 14 about 6-8 months ago to 16 to 18 as the major release. So right now everything here is about draft 18. And it is evolving very fast. That is one of the things. It's really hard to keep track of what has been standardized, what has not been. So this is the data model. I think this is the overall, in one slide, very, very high level. We can go into details later on. Don't want to bore you with that, of how the protocol works. Of course, there is control plane and data plane. Control plane is setting up the feed and subscribing to the feed, whereas the data plane is basically quick stream and datagrams with some of the metadata embedded in the streams, like we heard before, that allows the players to make intelligent decision, and that is part of the protocol. This is the MOQ data model. You have the namespace. Then you have at the top, this is hierarchical model. You have tracks. Within tracks, you have groups, subgroups, and ultimately the object, which is the smallest unit that goes into a MOQ transport stream. And then you can have, the beauty of this is you can have multiple tracks. Like we're talking about catalog, for example. Catalog is a specialized track. And when a client or a subscriber says, I subscribe to this particular feed, it can basically get a time track, a catalog track, or an ad track, and we'll show some examples about that. Multiple tracks in the same stream, and each of those tracks can give unique identifiers or things for the player to say, hey, I don't want this, or I want this, based on what the track has in it. So there's a lot of ability to embed a lot of information in the track. This is a more complicated, or slightly more detailed diagram. I did not make this. I used Codex, but I had to feed it a lot of information to get it in this shape. So again, the same thing as before. There is the publisher that publishes name tracks and media objects, the relay, or in the traditional sense, the CAS will do relay forwarding. Subscriber will request tracks and receives objects, and then the application will do the play out, right? And then this is where it is really, I find it really neat, because yes, it is for video, but this can be, the object can be anything. I can send non-video things to it on the track. I can send something like ad markers separately from the video track, saying at this time here is an ad marker, play this. Things like that. completely separate. Or we can send in track like reduce your bitrate, or at this point there is, I don't know, metadata saying, like you can send multiple audio tracks and say, the player can say, I want Spanish. They can just select a Spanish track and just get that audio. And you can synchronize all the tracks with each other, which means that you don't have to, like what happens today is you actually send, if somebody switches from one language to other, you are changing from the origin itself in traditional video. In this case, your video stream can be there, and you can start switching languages or subtitles, possibilities of this thing. Hopefully that is not, there's something that's parked right there. Almost like, yeah, try. It's the one right there. So object hierarchy, namespace, and there are some examples there. If anybody is familiar with the namespace, yeah. You guys want to add anything on this? Yeah, Matthew here has been spending a lot of time on namespaces, so I'll let him add any details here.
So the namespace is a logical grouping of related tracks that are often associated with a single event being delivered. There are options within the protocol to have events that have multiple namespaces for potential organizational usages, but for the typical deployment patterns that we are planning and what we're working on, we consider a namespace to be functionally equivalent to an event. So one origin, one set of inputs maps into a single namespace, and then we can route that namespace through the relay network to whichever set of receivers it's relevant for.
Thank you, Matthew. There's some more details here, between control and data plane. Terminology, your session setup basically is negotiates the version, set up the parameter, endpoints, and what kind of behavior the thing has. Publication is basically the publisher announcing the namespace, and it sends the data objects. Subscription is, subscriber request a track, namespace, range, priority, and delivery behavior. That is what, your player or client will request. Fetch, it pulls bounded historical objects useful for join, repair, rewind, cache, and cache use. You can also have priorities and timeouts. And then the relays sit in the middle and, basically perform the forward cache, merge. You can also direct the relays to do some things, like, certain things based on the track information. So you can basically embed all that information in the tracks. Like what Matthew was saying, the way we are looking at it is the namespace is tied to an event. And so if you have an event going on, we can send information to the relay to do certain things during that event. I don't know, endless possibilities, and we can, add control signals, for example. Like, you may have a broadcast where there is no ads, or you may have a broadcast where you have ads, and that could be specified in the event itself without having to worry about, how do I manage this, or having to worry about inserting Scotty markers on every stream that goes out, or ID3 or something for the ads to take place. Now, how does it differ from SLS DAS? Fundamentally, the primary difference I always see is mainly TCP versus UDP is the starting point. But in terms of the application layer, HTTP request, there's three-way handshake. You have playlist plus segments, whereas with mock, you just have a persistence pops up. Latency, because you are the whole segment chunk duration plus playlist plus CDN behavior. So, I think every time you request a 5-second or whatever length chunk, you have to wait for that to get buffered and you play. You can do things like LLSLS where you can start playing after the first second is loaded, but it is not continuous. Whereas with mock, you can do that differently with timing and priorities. Caching, obviously, HTTP caching is very, very mature. Every CDN will support it, whereas with mock, maybe some CDNs will support it today. It's not there yet. Adaptation like ABR for HTTP is very well established. ABR on mock is still, I think draft 18 is still not very clear on how adaptive bit rates works. We've done some work and we'll do a demo on it, how we made it work, but the standard ISN is not there yet. HLS-DAS interactivity, like, it is a add-on sidecar with most of the interactive things we see with streaming today, like live ads. Whereas with mock, it is, you can target ingest, distribution, multiple use cases with interactivity. Obviously, deployment, there's universal support for HLS-DAS today, whereas mock is a DAP protocol, and outside of reference implementation, I don't think I've seen anything out there in the wild today yet. So these are the standardized and snapshot. The mock working group at ITF. Very, very core draft. Draft 18 is the top. There are a bunch of supplementary drafts floating around already on how to do authentication, how to do, CDN selection, how to do security. There's a couple of other drafts that are still floating around. It's not made it to the draft status as per ITF, but there are, in the working group, ideas have gone around. There is parallel work being done, and one of the things with the ITF is, it's a lot of interest groups or people with different engineers with different kind of interest, and so it is going to be a very generic thing made by committee. So there is separate efforts to kind of work on media streaming specific use cases. And so there is a whole MSF media streaming format thing being proposed primarily as a format on top of mock, but it will likely not be part of the mock standardization effort, but be done outside of it. So yeah, there is a lot of standardization work. The target is to basically have a stable release by the end of this year. So I expect that around October or September, October, when there is an ITF meeting, I think that is when it'll go into sort of more of a consensus on what the draft would look like for mock stable releases. This is what the industry looks like. Somebody was telling me that at NAB this year, this was the buzzword. Everybody was talking about mock, which is kind of nice to hear. So there is a lot of interest. Obviously, the standards groups are there, mock and things. There are also other wrap, lock, things like that coming up about, okay, how do we adapt our formats to mock? NAB, I heard, was big with ATEM, Cloudflare, ourselves, Broadpeak, Red5, whole bunch of people, offering or showing demos of different use cases with mock. Open mock is collaboration, industry collaboration body with a bunch of people that are also in the ITF working group, but wanted to move faster. So Open mock is pushing for faster implementation and looking at expediting adoption. Browser, you can use web transport. I don't think there'll be a lot of work done on that space. And then with CDNs, there is a kind of, I think it is not settled how CDNs are going to support it over long term. But they are getting there, like with, at least with Akamai and Cloudflare fully committed to it, and others, even if they have not publicly stated it, they have been privately talking about it to make it happen. So I think it's a bit of a chicken and egg, because they want customers and customers want CDNs. So it'll probably be a while that goes on. Again, this is the challenges we've seen, and we've been working on this for almost 2 years now, even before I came to Oracle. CDN fit is a big problem, convincing CDNs to do it. The infrastructure layout is what we have found is, okay, where do we go do it? We don't have operational maturity, how to do DRM, for example. Where does that sit? how does the origin work, shielding, like for all of that things that we take for granted is still unknown, and that has to be sorted out. Security and auth, like relay visibility, there is still a debate about what kind of logs a broadcaster or streamer gets out of the relays, from hosted by a third party, what kind of data they get. It's still not clear. How do we pass authentication tokens between the broadcasters, streamers, or OTTs and the platforms? So some of those things are still getting played out. I think we are way ahead of the curve on that, some of those things, but again, there's no standard. So I said earlier about semantics, and there is, interop churn, like what we do today with mock. I can't guarantee that we can interop with all the other deployments of mock relays out there, out of the box, right? With some we can, with others we don't know, because we don't know what they've done. And then the really, really long pole is going to be device reach, because as I said, right now the only players we see are on the browser or headless, and I haven't seen anything on any device. But again, it's not mature to push it there. Maybe we'll see something soon enough, most likely on Android TV or Google TV, because Google YouTube is also kind of big on mock. So I'm hoping that moves faster, a lot faster than anything on Apple ecosystem. But that might be the longest pole of mock adoption, is getting it on devices. This is our own, view of things. It's going to be for basically real-time live experience. That is where it is going to be really big, both video conferencing and live sports. That is, I think, where it is. I think there is money to be made on betting, but that industry is, I don't think is going to be an early adopter. Or maybe they will be early adopters because they really like their low latency capabilities. Who knows? That is the killer, app for mock is betting. It is not going to change anything with HLS DAS. It is not going to be in short term a replacement, maybe for live, but I think it's just the pie is going to grow bigger with mock. The standards clock, the core transport and companion drafts are moving towards late 2026. I think, watching the conversation, I think by the IETF in October, the core draft should be done. And practical strategy, how do we, like this is the kind of stuff we're doing, like what is the fallback, how long do we have to have HTTP fallback before we can say, no, mock is the only way? I think those are some practical things to do. Okay, so now that is the dry part is over. I'll ask Matthew here to talk about the fun part. The fun part is like, we are part of, this is the corporate speak. We are part of the Oracle Video Edge team. We're basically a media services group within Oracle Cloud, formed in the last 18-ish month to bring low latency live video ecosystem to multiple customers. And this is our own, this kind of thing disappeared, but this is our own measurements we've done with mock versus HTTP. The median TTFF for, is 11 times faster with mock versus traditional HLS DAS. And then, you can see what I like is not the median. Median is never a good metric, but even at P95, you can see it's still 4 times faster for TTFF. We can debate if that is a good metric or not, but that is what we measured, in terms, because that is kind of, I don't think it's a good metric, but that is what the industry believes is a good metric, so we measured it. And then we also looked at network efficiency with overhead, right? How much overhead we had with MOC versus STTP, and with MOC we got 7 times lower overhead in terms of protocol transmission and things. Were any of you part of this measurement? Because this happened before I joined Oracle, so I was not too deep into it, but this is something that we can reproduce, and we've reproduced a few times, and it's not been any much different, even with the newer protocols. I think the next time we do this with the new implementations, we should get actually better results on this. Any questions on this? This is what Oh, any questions on this? Okay. So what Matthew will show is a demo of this thing here, and that is your demo.
Yeah, so I'm going to go through a demonstration on ABR switching and MOC. The video is only 90 seconds long-ish, maybe less. So essentially, this is a real MOQ relay hooked up to a web transport-based player, and the difference from the traditional HLS world is in HLS, switching bit rates is just deciding to pull a different file next. So I'd make a decision at the query level, but in MOQ world, you have one established stream that's interfacing with the relay that's providing you with the content, and you now have to do track switching via a subscribe to a different track to acquire your new content for a different rung on your bitrate ladder. That gives us some cool advantages, like the ability for the server to actually guide what bitrate decisions we make. And if we play this video, this version is running client-side, but it's demonstrating some of the metrics that we track and use to make decisions on the client for when to do a switch. We do that by looking at how much buffer we have left and scheduling an object upon which we will need to transition from our current rung of the ladder to the next, so that it's frame perfect, since the given tracks are aligned object by object. And so we pre-subscribe. There may be some overlap in the actual signal being transmitted briefly at the transition point. So if you could hit play, please. We start off with a clean network. And this is putting a MOC relay into a Chrome web browser. And then I'm going to force an impediment, which will cut the bandwidth down to 4 megabits. And you can see there that now we've dropped the bitrate to the 720p track, and the decisioning logic is played out in the feed below. You can ignore the broken last sample bit size counter. The rest of the numbers here are describing the data points that we use to make that ABR ladder jump decision. And the goal is to make it seamless and low latency. We're not solving a new problem from HLS-ABR adaptation here with just the client-side implementation, but we have a different set of inputs to work with. It's no longer just make a different request. It's now we have to schedule a change in the future to cut over between tracks. And if the playback continues, there'll be one more impediment where you'll see the data will then fall down to even lower bit rate and force it down to a 480p rung on the ladder. And that will cause the bitrate shift. Now we're on 480p. And once the network, we can keep playing. Once the bandwidth gets cleared completely, the upgrade gate will allow, and notice the bitrate is done, and we'll pass, and then it will be able to jump up to 720, and eventually back up to the 1080p rendition on the ladder. So ABR switching is an active development area in the MOQ specification. There are client-side and server-side proposals. We're starting with a client-side model in our product offering, but we are actively investigating where it makes sense to do server-side switching. There are some interesting use cases for a distribution service, such as pruning catalogs to congested ISPs, because we have such deep control over how video is routed across the internet. If we discover that Comcast customers, for example, are having a bad experience with our stream, we can prune the MOQ catalog for the namespace to remove the 1080p rung. And that will force all downstream clients to do a bitrate shift to, on just the Comcast downstreams, do a bitrate shift to a lower rung, thus freeing up bandwidth so that the average viewer experience is preserved and the few people who are getting the higher resolution get knocked down, but then everyone else can still watch the game. So it gives more tools for event operators to manage the life cycle of an event and protect the average viewer experience in aggregate form. Yeah, that's AVR switching and MOQ.
What Matthew said is one of the things we were talking about earlier with this approach is if there are two events going on at the same time and a customer wants to protect one event, like we had those two soccer games going on, and if we want to protect one over the other, then we can easily drop bit rates on one event only and let the other one go higher, so that continues to get better experience. And that could be the case during, say, the Olympics, where you want to put the 100-meter sprint on a really high available everything, whereas you might put, I don't know, I don't want to deem in any sports, but something that is less popular, like a marathon. They run for like almost 2 hours, so we can watch the 100 meters dash, and the marathon can be on a lower priority. So that is possibility. So the next demo I have is from This is, I don't need the slide for this, we'll just move there because this is about AI-generated metadata over live media. Extending. Mirror. Yep.
Hello everyone. So the demo I'm going to show is we want to show how we can use AI analyzer and work with MOQ. And in this diagram, at the top level is MOQ modules. The first is a publisher. It will publish the contents, the media, into the MOQ relay. So the main purpose of the MOQ relay is for the fan out. So here we only draw one, but one MOQ relay, it can connect to multiple relays. So it's easier for MOQ to fan out the contents to millions, hundreds millions of players. And the player, they will subscribe to one MOQ relay, and then the video, the media will go to the player. And the media analyzer is an AI module. So this it will watch the. So this AI module, it will also watch the contents, and based on the configuration, it will try to find the moments we defined. So in this demo, the content is a soccer game. So the AI module will try to find when the goal happens and create the event. And then it will put those event metadata back to the MOQ relay. And those metadata will put in one event metadata track in the MOQ. So it will be easy to send those metadata events to the player. And at the same time, this media analyzer will also find when the replay happens. So when the replay happens, it will also create another event to tell the player. So the replay is identified. And on the surface of the player, the viewer can begin to watch the replay. And this media analyzer will also save these replay clips in some storage. When this is ready, this event, the signal will also be sent via this event metadata track to the players. So one benefit of the MOQ is it has all the tracks, and those tracks can be customized. We can add more tracks as we want. And on the player, when it subscribe to the MOQ, when it get the catalog, it will see all those tracks. So those tracks will be very convenient for us to send this metadata, add breakers, anything we want. So we can do a lot of things. So the next, I'm going to play back the video. So this is the player, the surface of the player. This is not production. It's just for the demo. So on the top right, left, this is the video game, the media data from the MOQ relay, and on that part, we can see this is the event feed. So this event feed is an event metadata sent from the metadata track. So when some goal has been identified, so it will send the feed. We will see here goal confirmed and what is time it is. And then when if the replay is ready, this panel will show, okay, the replay is ready, and if the viewer want to see, it can click that to play back. And on the timeline here, maybe it's not clear to see. Here is a timeline. This is a timeline. And those red dots are the time when we identify the goal, the time when it happens. Okay, now the red color, when the replay is ready, it will show the customer, show the review, the replays okay, so you can play it back. So all these events is from the MOQ metadata track. And so in this clip, we have 3 or 4 goals. And when it happens,
I think this is just an experimental thing we did because the company keeps telling us use AI, and and so AI for productivity is one thing. Everybody is now using Codex and whatnot, but we're like Harry in our team is not here. Alongside the rest of the team, kind of said, okay, let's try to do something that is on the fly. As I said, he's basically looking at this particular scoreboard here to verify that the goal happened, and then obviously marking it here, like it's not very clear in the screen there, but this is the replay, and clipping it based on that detection, and then making it available for everyone. I mean, we can go from beginning to end of this thing if.
In the MOQ sense, the value that MOQ protocol is adding to enable this is a uniform platform. MOQ is adding a uniform metadata platform via the namespace encapsulation. So the AI detection metadata track can be written as a new track in the MOQ namespace. So any subscriber in the whole network, be it the downstream engine that then can confirm that you have actually gotten a goal, or a clipping engine that cuts out VOD clips and exposes them to your client-side app, can consume that metadata track in the same way it's already getting the video and the rest of the production. So it provides a standardized, low latency vehicle for delivering synchronized metadata along with the actual media content tracks.
I think the fun use case is like then this can be sent directly to social media, Instagram Reels or TikTok or whatever, because that is where the demand is coming from. Is like, how do we get these clips quickly enough out before somebody does it, on their own? And so that is probably where this is gonna be. I'll just play this end to end, the whole thing, just for you to. Was this? I think. Okay.
what is happening right now?
We're just doing the whole thing end to end, if you can follow that, but this is a demo built in one screen, but the idea is, yes, this is, the recording, we moved the screen up and down. But the idea is, the thing we saw in the bottom, the clip, there's a URL with it. And so the operator would paste that into some other platform quickly. Or if the user, depending upon how the player is built, could say, I want to watch a replay of goal 2, that is already a metadata there. They can just click on that, then they can replay that as many times as they want, and not be completely dependent on, the broadcaster deciding to replay or not, right?
Yeah, so just after broadcast clips, may they be called this or whatever you want, nomenclature you want to use, you have people, folks sitting in the courtroom manually clipping these things after things are happening. You're embedding AI to do these clips on margins here based on goals or scores incrementing, things like this, and doing smart scene detection and creating clips on the fly, right?
Yeah, and I think the driver for this was more about, as you said, there is the manual work involved, but also the experience that we know is because it's very difficult for, say, streamers or OTT or broadcasters to do that replay on the fly, inline. People are going to a different platform, like either YouTube or
YouTube,
TikTok or something else to watch the replay. And again, as an engineer, I don't know, but as a business, people want to keep everyone in their platform. And so some of these things are just allows for that.
I'll move the mic over so you guys can use it.
I just have a question. As someone who's building a live production system, getting material cleared for demos is like impossible, especially for sports. How did you manage to get FIFA approval for what you're doing? Okay.
Private event.
We every time somebody uses the big bunny for demo, they have to apologize. So I think Harry decided that. Yeah.
All right, I have 7 questions. Are we ready? No, I'm serious. All right. I'm going to start with a statement. Persistent bidirectional connection for streaming coming from Flash Media Server era. Persistent connections between the client and the server were critical. When we went to HTTP, we lost a lot of that. We've rebuilt it. MLQ is the only thing I've seen besides OctoShape. That's a slight to Akamai. That has even offered something like this. So just really quickly, are we excited about the possibilities of bidirectional communication between the client and the server for streaming?
Yes, and if you got the drift earlier with the ITF, the video conferencing people are all about bidirectional. Our focus is mainly on live streaming, so we have not done as much. But as a protocol, the entire camp that is mostly Cisco people are all about bidirectional because they want that for mock. We, on our side, are thinking that maybe we can use MOQ bidirectional to collect metrics. But again, that is very, very, thought process right now because the protocol is not there yet.
Right. And
unannounced things.
Yeah.
Yeah, and even like at FIFA, when we have the metrics coming down for the different differentials of the game itself on the side, that could be a separate stream, a different publish and sub mock, and then so this goes into my next 3 questions, which are all basically the same about ABR. For adaptive bitrate decisioning mock, where do the core heuristics live? Is ABR primarily client side, server side, or mixed depending on the architecture?
Yeah, it's still being developed in the specification, so the answer is it's not finalized. We are speculating on a initial client-side model where we will drive things on the client, making the decisioning via the metrics I demonstrated in that recording, with the additional server-side capability to do catalog pruning. Just that one capability to force everyone downstream of a certain point to consume lower bit rates. But there are allowances in the specification, and we are making allowances in our design to support server-controlled bitrate switching as well.
That's great. So my next question is around the downstream manifest manipulation, like you just touched on. But so like what we had in flash media days was like burstiness or capacity at the CDN edge and things like that. So to me, ABR really shifted to the client once we went to HTTP, and it failed to do all these things that were unknown upstream. We use CMCD to push these through. We use other things to try to send information just to debug these things. But to me, it seems like if we're going to make mock work, we need to have the knowledge of the edge and what's behind it, also what the end user and the client side is going to have to make this ABR really world-class, like television broadcast it was. Not that there's ABR there, but stable and high quality. All right. You mentioned using real bitrate data, possibly manipulating the manifest. How are you determining the actual availability bitrate or quality in real time?
So the specification itself does not tell you how to make those determinations. The specification is about the actual protocol. It's up to players and relays to make those implementations. Our product, Oracle Video Edge, which we have hinted at and announced, although not fully detailed or released yet, has an extensive metadata system that will be attached to our offering that will be collecting telemetry from every relay along the route, including those run in Oracle's cloud and those run in CDN partner clouds, as well as direct telemetry from the player client devices, assessing things like buffer size and their network conditions on the ground. We then can aggregate that by ISP or region and do the kind of analytics to do that kind of strategic edge control decisioning. But that's not part of the MLQ specification directly. That's a part of our value add.
Yeah, that's awesome. And I think getting in on the ABR section of this specification is where maybe our team can provide some value, but not a lot, but some.
I'll add to that what Matthew said.
Sure.
This is more at a meta level. And the pun is companies like Meta and Netflix and Google, they control end-to-end. They control everything, like for the video stream, which allows them to do things that folks like yourself and in my previous job, Prime Video, which uses multiple CDNs, are not able to. Right. And so I think what we are thinking is, can we build similar capabilities using extensive metadata sets and provide similar functionality to like yourself and other streamers so that they don't have to own the end-to-end. And that is where it is going to be a bit of a push and pull, because again, when it comes to streaming and PII data, at the end of the day, somebody is streaming, and so you get into, do CDNs get to keep that data or not? Because at the end of the day, the personal information of a streamer belongs to the OTT, and they are held responsible. So there's going to be some friction along the way on how we standardize the granularity of the information that can be shared with everyone on the path. But what we are hoping to do is make it granular enough that it is actually effective, but at the same time, it is protecting or meeting all the compliance requirements, because we are committed to being multi-customer, multi-platform, right? We don't have a streaming service of our own. So that is where I think the meta-level challenges are in that space. Outside of the engineering, all the other stuff that has to happen.
No, I think that's exactly right. And owning end-to-end versus public CDNs and working through the stuff we've talked about privately, I think there is a future here for sure. And then that brings me to my next point, device fragmentation. So my big pitfall with this whole thing is I can't get this on all my devices in my reach. I've pleaded to my management that we should force everyone to get new TVs, and everyone's like, oh, we're not buying a new TV. Like, we have a Walmart Plus thing. Why don't we put a QR code and do some deal? Well, people want their TVs for 10 years, and so 2016 Samsungs are still around. 17 has enough people in Conviva to make it monetize, make it worth our while. But it holds this entire industry back. So we've talked to you guys about this problem from the beginning. You have some solutions. Is there anything you can talk about how you would approach this problem publicly?
I think.
No, we will not.
I think
Totally fine.
There's a good part of it is, given YouTube has been on QUIC for the last, I don't know, 10, 12 years, I think the path to getting there is slightly easier, mainly because of protocol level support. And you talk about 2016, until what, 8 months ago when I was at Prime Video, I was dealing with 2011 and 12 LG Hawaii that only did smooth, right? So Prime Video still supports smooth streaming because there are 750,000 devices doing smooth, all right? So those devices, you can't even upgrade the firmware, but I think we are looking at it is once we get traction, as I hinted earlier, with Google TV, because Google YouTube wants to go on Mach, we may see slightly faster, but when it comes to Apple and the iDevices, it's a longer pole, but living room wins, right? And that is 70%-ish, at least in most of the developed nations with high live streaming. So, but yeah, there is no fast answer to that.
Yeah. It's the tough one. Just for reference, Samsung 2025 televisions across all the platforms, LG, Vizio, everything else, they all have Chromium well over the minimum viable web transport and web codecs level to do Mach, and none of them have that implemented on their TV. They've stripped it completely out of their version. So how do we do this when people are buying TVs right now and we're going to bring it out there? So there has to be other solutions. There are other solutions to cloak this, but we'll leave that alone for now.
Yeah, our fallback strategies we can't talk about right now, but I can say generally one of the upsides of MOQ as a newer protocol with latency and VQ advantages due to being able to be more efficient with protocol overhead and things like that is that it can be somewhat of a halo magnet to incentivize upgrading over time. So you can have a dual delivery stack that supports legacy clients, and they have a natural incentive. If you are, say, betting on FanDuel, you want a device that has the newer protocol capabilities and will let you receive the stream 3 seconds before your neighbor across the street who hasn't upgraded his TV. It's not an instant solution, but it gives an incentive to try to improve that situation.
Yeah. Actually, I will add something. My background is in network engineering. That's what I did for almost 20 years before I entered video. And what I do like about MOQ is, today we talked quite a bit about delivery and the client facing. MOQ as a protocol, as it mimics some of that things about multicast, like fan out, relays, replication of video, use of MOQ on the contribution and mezzanine feeds is something that might go much faster and bring a lot of that efficiency, because now you're not, even if you're a CDN, you may be able to use MOQ to get the bits to the edge. That reduces your overhead and everything else that goes from the edge to the origin, and that improvement we might see a lot faster as a benefit while we still work the whole device churn.
Right. So you can partition this a bit, get some benefits in some of the parts of the network, not all the way through end to end, but work on that as time passes through.
And that is what I see. Again, not many people believe in that, but I see that once it is proven, it's going to take off very fast.
It's the only way to move forward in these fragmented world. So, okay, for fun, I'm sorry, thank you for dealing with my 10 questions, all generated by AI, but just pressing. All right, I'm kidding. I did write some sloppy notes and then converted them into real questions. For ultra low latency sports, okay, this is about your demo. You mentioned bringing in the scene detection around the goal and then the scoreboard itself incrementing up. So my question is about VAR. For ultra low latency sport, what happens when live state changes after the fact, like a VAR review? So we went to 2-2, all of a sudden there's VAR, it goes back to 1.
I think the answer is we don't.
Well, welcome, Kevin. He's the soccer expert.
Hi, everyone. So in this demo, we're using Quen, multimodal language model, to analyze every frame for specific criteria that are related to the sport, right? So anytime something like this is going to be deployed, it's going to be running queries on the images that are domain specific. And this is a very simple example where we're looking for one thing happening, which is the goal. But this can be parallelized, right? This scales horizontally. You just spin up multiple media analyzers that look for different criteria. And if you have a domain expert that can predict a scenario like what you're describing happening, it's easy to include an additional metadata event on the metadata track that describes the change, the reversion in the score that could happen.
It makes sense, and also it's still a relevant clip, because even if it was a reversion or a pullback of the goal, people want to see that key moment or that key clip regardless, and still it's.
Yep.
So you are able to follow frame by frame through the progression of the scenario.
Yep, this is frame by frame analysis.
Awesome, thank you very much. Any other questions?
Is your AI thing tuned or looking at the audio for cues at all? Because we find that it's usually they say goal way before the score changes.
Yeah. This demo was mostly to find some use case that would leverage the metadata track. So no, in this case, we were not looking at the audio at all. It's purely frame visual analysis. Well,
Early goal break notification.
The capability being demoed here that we are planning to offer is not the AI system. We expect third-party partners to develop those systems. We are offering the MOQ metadata transit track to be the backbone for those systems.
I mean, this can evolve, right? I mean, if you are a broadcaster like Fox has the rights or Peacock, and you have camera crew on the ground, instead of us waiting for this, they can actually just point a camera to the scoreboard in the field and have that over very low latency. That can be analyzed, and the thing can actually detect goals before it shows up on the screen. So I think the possibility is, and this is just a way of us, that is a
Real-time low latency data from the stadium through some kind of lab.
metadata track, and exactly. And that could actually, this whole thing about social media spoiler then becomes a non-issue at that time.
And then second screen, I think Mach's a big win there on second screen, like whether it's chat tracks or things that are aligned and synchronizing up with the delivery of the video on the main screen. So we don't need to get into more use cases, but any other questions from folks in the room? Absolutely not. Yeah, it's time to go home.
What's the killer application for MOQ? I run a service that runs millions of concurrent HLS subscribers as well as hundreds of thousands of concurrent WebRTC subscribers. I get the benefits to me as an operator of MOQ, but I'm curious what you think the killer application of MOQ, and who are the most incentivized commercial benefactors in this entire ecosystem for making MOQ a commercial viability?
Two parties. One is people who are looking at super low latency, like video conferencing, because today video conferencing has a massive amount of overhead between all the nodes, right? You are on a 20%, 30%, or whatever number of video conference parties, then that is all doing web transport, at least in case of WebEx, and they really want to use that, because that way, if, say for example, today you are in an office and 10 people, like very common these days, if you have 5 people from the same building joining the same stream, that is each an unicast and each an overhead. With something like Mach, it could go to a relay localized and then just get one stream, right? So there is that is where it's coming from. And I think Cisco's interest is they are going to do MOQ relays on the switches. But that is one interest. The other one Matthew was just talking about is, I think there are areas like security cameras, from where you could get feed, like it could serve as a kind of video sensor network, like a video IoT, because the scaling at that point, because it pops up, you only need to subscribe to something, and then when the video is there, it can keep getting it. If it shuts down, don't worry about it, right? That allows that level of control where you don't have to maintain state and be actively monitoring something, which already happens quite a lot. Well, that is how IoT mostly works, is on pops up. So that is another one. And I think the killer app is probably going to be one of those two for protocol adoption. But what we are looking at is very, very large scale video live streaming. Now, there are not many events that are exclusively on the internet, but even when Netflix did their that whatever boxing thing they did, they had to learn a hard, difficult lesson, right? And it took the likes of Netflix to get it right, and Prime Video does it every week now, Thursday Night Football. Doing something at that scale, you are literally breaking this boundaries of the internet already. And anything beyond that, like if you think of Super Bowl with something like 30 million people concurrent expected in the next 2 years, the internet is not going to cope with that, right? And that is where this yeah, that. But then till I think
In 4K.
that is where I think the younger generation will say, who wants to watch TV? I'm not going to watch TV. I want it on my handheld device, right? And that is where the transition is coming into more and more streaming demands. And some of us have been on the front row of that, of how that has been changing. And I think that is where this is going to be really be important. And that is where all the innovation will happen. And hopefully everything downstream will benefit from it. This is, for me, I think it is the scale that it can support is the killer app. But again, the flip side of it is not many people need that scale. So
Yeah, I think scale is the critical thing for a lot of companies. I think the killer app is government drones. All right, so at this point, yeah. So, and they like that quick protocol. All right, so put our hands together for the Oracle folks talking about mock and having some fun with it.